Okay, Mingalapat to everyone, and also, good morning to you all. And first of all, on behalf of ICANN, I want to thank Nog for giving us this opportunity to talk about this topic that I'm going to present. So my presentation is going to be on universal acceptance, or simply we call UA, and also email address internationalization, simply we call EAI. So let us try to get into some definitions and also try to understand what are we trying to achieve here. Now, as you can see in the slide, when you say that you are universal acceptance ready, the whole idea here is that the old domain names and the email addresses should work in all these software applications. Now, sometimes you might wonder, why are we talking about it now? Because we have been using domain names for a long time, email addresses for a long time. It has been all working in software, right? But the thing is that you also have to understand that the DNS, the domain name system, has evolved quite a lot over the years. So with the evolution of DNS, we have to also think about whether our software and various applications can support these various domain names that we have now, and also the different formats of email IDs that we have. Because in the world, more and more people already have started using these different domain names and different formats of email addresses. That's the context of this talk. Now, just to give you a brief recap of the evolution or the expansion of DNS over the years, DNS was actually the first earlier, the RFCs were published a long time ago, about 40 years ago, in the early 1980s. So that's when the DNS was sort of designed. Since then, there have been many sort of evolutions in the protocol itself, and also when you consider about the namespace, the top level domains has evolved quite a lot as well. As you can see here, if I just try to put that into three eras, say initially before 2009, there were these generic top level domains. These were, quite standard historical ones, that what we call generic top level domains. Mostly during very early days, these were 3-character domain names like .com, the top levels I'm talking about, .com, .net, edu, and so on. But then after like 2000 or so, year 2000, we saw that top level domains like .aero or .travel, .info, these were added. So currently we have about 22 of these generic top level domains now in the DNS. And also during this time, many of the countries, basically, when the internet was expanding to different countries as well, the different countries were also given 2-letter country codes. So they were, for example, Myanmar was delegated .mm, for example. These are called country code top level domains. In Australia, we have .au or Singapore .sg and so on. So currently there are close to about 300 of these country code top level domains exist in the DNS. And then after like 2009, we also saw that non-Latin scripts, because previously mostly we've been using Latin-based scripts like English, for example, and ASCII-based scripts. But then after like 2009, the internationalized domain names, or IDNs, were delegated. You can see a few examples where you can see top-level domains in different scripts, because in different countries people write, or people have different scripts. I do not have an example here for Myanmar, mainly because in Myanmar, there is, as far as the top level domain is concerned, there is no CCTLD string or Myanmar in Myanmar script for CCTLD for Myanmar. So this is something that maybe the country code top level domain, like for example, PTD can also work in the future. Getting CCTLD IDN string for Myanmar as well. And then like after 2013 or so, there were new generic top-level domains were introduced into DNS. So these were outside of those traditional ones that I was talking earlier. Say, for example, like .sky or .bank. There are cities like .melbourne and so on. So currently there are around 1,200 or over 1,200 of these new generic top-level domains exist in the DNS, and also the ID and GTLDs. So this is actually some sort of recap, very quick recap of the evolution of the top-level domains in the DNS space. So when many of these top-level domains are being delegated, say in more than 3 characters, or the long ones, or IDN ones in different scripts and so on, it is also, we have to make sure that our software, the applications, can also support these changes. So this is the whole discussion that we are going to focus on. Now, before we really get into more details, let's try to, zoom into a domain name, right? So this is an example domain that you can see, www.cafe-123.com. So here, .com is the top-level domain, right? So this is a generic top-level domain. Now, there are some certain rules, actually, when you define top-level domain, say or when you define a domain name. When you consider a top-level domain part, say in this case, .com, so that is the top-level domain, we can only have letters, say in English, from A to Z. We cannot have things like numbers as as part of top-level domains. This is this is defined already, right? So someone might ask, okay, why can't we have numbers in the top-level domain? Then there could be a lot of confusion. Say, for example, if someone picked 123 as a TLD, then this can be easily confused with an IP address as well. So because even in domain names, you have different labels. So people can select numbers for all these labels, and this can be easily confused with IP addresses as well. So anyway, as a rule, of course, in top-level domains, we cannot have numbers. We can only have letters, say from A to Z. Now, when you go to, say, second-level domains, you can see that, again, there are certain rules. We can have letters from A to Z. Also, we can have digits from 0 to 9, and then we can also use hyphen, right? As you know, in your keyboard, you may have a lot of other characters, right? You have a lot of, say, the star symbol or the percentage sign, all these different characters. But we cannot use all that in domain names. So even in second levels, we have to use letters, digits, and hyphens, right? So these are some basic rules when you try to consider a domain name. Now, from historical days, we have been using ASCII, right, to define these strings or labels or domains. This is a snapshot of the ASCII table. Now, ASCII is a standard. ASCII stands for American Standard Code for information interchange. So that is the sort of meaning of ASCII. And ASCII was defined long time ago. But at that time, of course, the main requirement was to define the English alphabet, capital letters, simple letters, and then the different characters. So for that, ASCII was enough, because ASCII could give us possibility of 127 character mappings, because it was based on 8-bit or single byte representation. So we could go up to 127 character representations. So this is just a snapshot of the ASCII table. So you can see here that, again, even though you have 127 characters in ASCII, we cannot use all those characters in a domain name, because based on our earlier definitions, we can only use letters, digits, and hyphen if it's a second level domain. And if it's a top level domains, we can only use letters. So you can see that if you see the highlighted part, some letters are highlighted in green or outlined in green. Some, in this case, the English alphabet, they're all covered in green. And then the numbers are all highlighted in blue. And then we have the hyphen, which is actually outlined here in red. So these are the only representations we can use in domain names. Other symbols or other characters in the ASCII table, we do not use for domain names. Now, let's see if you are to type a character in Myanmar script, right? So if you are to represent, say, for example, if you are to type a string in Myanmar script, that means we have to have a representation for that Myanmar script, whatever the letter, right? But the problem is, in the ASCII table, we don't have space now. There's no any available space to put that Myanmar character, right? So this is where the problem is. It's of course, it's not only Myanmar. Even if you go into different other countries, say in China, there are lots of characters in Chinese scripts. In India, there are many different scripts that have been used. People use, so we get so many of different characters, or simply we call glyphs, in different language scripts, where we don't have enough space to represent that in ASCII. So this is why we have to have some other encoding scheme other than ASCII to represent these other scripts. So let's now actually try to focus on a domain name written in Myanmar script. So this is given that most of the audience here are from Myanmar. You can read this. Basically the idea here is, or the English meaning of this is universal acceptance.test. That's the equivalent translation for in Myanmar script. But the thing is, this is not a real domain, so don't try to visit this or access this. This is just an example, a test domain that I have taken for this presentation. So in this, again, those rules that I mentioned to you is being applied, that we cannot use numbers in top levels and so on. So those rules will be applied. And these rules are all defined in a standard called IDNA standard. So IDNA stands for Internationalized Domain Names for Applications 2008. So 2008 is the current standard. There was a standard before, which is 2003 standard. So that was outdated now. So we always have to follow, in case if you are involved in developing these applications and so on, you should be referring to IDNA 2008 standard, not the 2003 standard, right? So this is, again, just a snapshot of the Myanmar scripts or the alphabet. This is where we use to represent this. We use something called Unicode. So this is a snapshot of the Unicode table for Myanmar scripts, because I told you earlier that ASCII table is not enough. We don't have enough space in ASCII, so we have to go beyond ASCII to a different other encoding scheme. So here this is where actually a consortium was established called Unicode Consortium. So once the Unicode Consortium was established, we could represent different characters, different scripts in Unicode. Say, for example, that in Myanmar you have all these characters. I'll pick one. I believe this character is cha in your language. So this would be defined as 1006. So that is the Unicode representation for that character. So that's kind of, just a very quick overview of this representation. So this is where, so we are going to use Unicode to encode all those glyphs into code points. So glyph is basically the character, the script that in your language, as I said, cha, for example, this one. So this is the cha in Myanmar. So this is the Unicode representation, and we will also have a U to mention that it's a Unicode representation, and then 1006, that is the code point for that particular letter. So like that, all those letters in your character or in your language can be defined in Unicode. Now, when we have to actually use Unicode, again, in Unicode, there are different formats. There are different formats that we can represent. Just like ASCII, there are different other schemes. Say, for example, UTF-8 is one of the schemes. And then similarly, there is something called UTF-16, UTF-32, and so on. So these are all based on the number of bytes that is being required to store and transmit the bits. Because, as you know, even when you press a key, it is a bit stream that goes to your device and in the wire to the other end, right? So everything is a bit stream. So this bit stream has to be unique and uniquely represented, and this representation has to be done in this case using UTF-8, right? Because UTF-8 is actually quite optimal in this representation in comparison to UTF-16 and 32, because UTF-8 is optimized for things like storage, transmission, and so on, right? And also, other most important thing is we don't have to change ASCII, because ASCII has been there for so long. So we don't have to change everything now, because by introducing UTF or UTF-8, we don't have to change the ASCII representation. So it is basically backward compatible. So this is why we use UTF-8. In fact, nowadays, in all different protocols, web protocols, applications, and so on, we use UTF-8 as the standard. Okay, now, based on these things, what we have discussed now, let us try to, apply this into universal acceptance readiness. I told you UA, or universal acceptance, means all those domain names or email addresses can be processed by application, or not only process, understand, accept, validate, process, store, display, everything, right, can be done by the applications. Now, in terms of domain names, there are new top-level domains like this, example.sky. This is not a traditional like .com type domain. It is a 3-letter character, but still it's a new top-level domain. And if you take this one, example.melbourne, the top-level domain is a longer TLD. And again, if you see this one, again, this is in Myanmar character, as you can see, universal acceptance.test. So this is again in your local language scripts. And similarly, even if you take email IDs, we can have different formats of email IDs. Sometimes our mailbox can be ASCII, right? In this case, our mailbox is an ASCII mailbox. And then the domain, part of the domain can be based on local language scripts. And similarly, our mailbox could be Unicode based, but the domain can be ASCII based. Or the mailbox can be Unicode, and also the domain could also be Unicode, but in a different script, right? And then now all these scripts actually you write from left to right, because usually in many languages we write from left to right, but there are some languages where we write from right to left as well. Like, for example, Arabic. In Arabic, we write from right to left. So this part is the mailbox and this part is the domain. So if you are to give this type of an email ID, if you are to use this type of an email ID in any application, if the application cannot recognize this, or cannot accept it, cannot validate it, cannot store it in a database, these are all problems, right? So that means we have to fix those issues. So this is why we are saying, by saying universal acceptance readiness, is to make sure that all the applications, it could be your databases, it could be your web applications, it could be your browsers, it could be your, anything, right? Should support these changes to domains and email IDs. Say, for example, if you today register for MMNOG using your own Myanmar script email ID, if the form rejects that, then we failed there, right? So we have to fix those. So that's the idea here. Now, we have done some surveys and tests just to analyze how the mail server supports for these different type of email IDs and so on. But currently, only less than 10% of the email servers, mail servers, can support these different, domains or different email IDs or local language scripts and so on. So less than 10%. So this is why we really have to, especially as sysadmins or network operators or whoever it is, if you are dealing with, say, domains, or if you are dealing with mail servers, you have to make sure that your mail server softwares can support these, your other system, operating systems can support, and so on, right? We have also seen that, we have also done some surveys using global top 1,000 websites. You can see that even most of those, they can still support only 3-character domains, but beyond that, there are many of those websites fail to support, right? So we have to fix some problem here. So in this case now, let us take a very quick example here. Say, for example, in a browser, right? If you have to type a domain name. So in this case, in this browser, you have to type your Myanmar script, domain name in Myanmar script, right? But then what will happen is browser, in the first place, browser is an application. So browser has to do something called normalization, right? Because DNS doesn't understand these local scripts. DNS works, DNS queries work based on the ASCII, right? So we have to convert this Myanmar script into an ASCII script. So this is something that the application has to do. So there's something called normalization should happen. What do you mean by normalization is, say if you take this particular Myanmar character, you may type this character using multiple key sequences, right? So if you're using a soft keyboard or a usual keyboard, sometimes you may write this using multiple key sequences to type single key. But the thing is, whether it's multiple key sequence or single key sequence, the character, the glyph has to be unique, right? So this is why the bit stream that we input to the device should be unique. So this is what we call doing the normalization. So we have to come up with an exact code point. Remember, I defined the code points earlier, and we have to have a unique code point for that. So this process is actually called normalization, which the application has to do. So if there are any developers here, you should be referring to that IDNA 2008 standard that I mentioned to you earlier. And then the browser will convert this local language string, in this case Myanmar string, into a ASCII code. Now this code is actually called a puny code. This is defined in a RFC. And usually, puny code, you can identify whether it's a puny code when you see XN hyphen in the front. So this Myanmar script will be converted to XN hyphen some ASCII string dot XN hyphen another ASCII string. Actually, this whole Myanmar script will get converted into this. So this is a ASCII label or a ASCII domain. So once that is done, the browser or the application now can do the DNS resolution, because in DNS, as we know, we just have to find the IP address. So this is what the browser will request from the resolver, asking for the IP address, right? So after that, the remaining stuff is the usual DNS resolution. So that's how a query get resolved. Now, when it comes to email delivery, as we know, there are, in the email delivery, say, there are different components in an email delivery path. You have mail user agents, then you have mail transfer agents, or we call MTAs. And then we also have, mail delivery agents and so on, right? So there are different components in the whole path, right? Now, for sometimes, for mail user agents, we may use very specific clients, say, for example, Thunderbird or Outlook and so on. Or sometimes you could be even using web-based clients as well. So whatever it is, you have mail user agents, mail transfer agents, mail submission agents. Mostly, mail submission agent is part of the mail transfer agents. And like that, we have different components in the whole path, right? Now, so the important thing here is that in this whole part, all those different systems we have has to support this email address internationalization that I mentioned to you earlier, right? The local language scripts, different domains, and so on. So if you consider the protocols that we use in this email delivery, SMTP, because between the mail transfer agents, we use SMTP or ESMTP. And then in the mail delivery agents, say from the mail delivery agent to the mail user agent, we use protocols like POP or IMAP, right? And all these protocols has to support email address internationalization. So the whole idea here is that if you are using these mail server softwares, right, you could be using in mail servers, mail delivery agents, and so on, make sure that you enable the support for EAI. That is quite important. This is just to show you a little bit of signaling between those mail servers. So in this case, like between two mail servers, say let's pick one server as a sender and the other server as the receiver. Usually, before the mail is being delivered, the mail servers, they establish a connection, and then they share some signaling to make sure that the email can be delivered. So once the sender is connected to the receiver can say it can support this domain and then the protocol, and then the sender can start sending the hello message or the extended hello message with the sender's domain. Now, after that, the receiver can mention what sort of signaling flags that the receiver can support. Say, for example, if it can support attachments, it will say it can support 8-bit MIME. And similarly, if it can also support the internationalized email addresses, that what we discussed earlier, like in Myanmar script, it should send this signaling flag SMTP UTF-8. So this is very important. So in your mail server configurations, you have to make sure that SMTP UTF-8 is enabled. So after that, we can send the from where the email ID is coming, and the recipient is accepted, and then we can start sending the data. So this is the usual, communication that happens during the email transmission. So the whole idea here is that the summary that I want to actually mention you is that, especially if you are to make sure that if you can support these internationalized email addresses, like in Myanmar scripts and so on, or any other script, Chinese scripts or any other language script, you have to make sure that your mail servers, SMTP, POP, IMAP, and so on, it is all capable of supporting EAI. So make sure that you have that enabling flags activated, right, in your configurations. And then, and also the other important thing is that, as we know, when an email gets transferred from sender to receiver, the email goes through many servers. So if, in case, say, if one of the server in the middle cannot understand or doesn't support EAI, then the email will not be able to deliver. We will not be able to deliver the email, right? And then the email delivery will fail. And then obviously the failure message has to be sent to the sender that saying that the email cannot be sent, right? So this is also very important. In an email path, we have to make sure that all the email servers in the path can support EAI. Sometimes also you have to understand that when you configure DNS, when you have your MX records in the DNS, you have multiple mail servers, right, with a priority. So make sure that all those mail servers can support EAI, because sometimes because depending on the email delivery path, sometimes it could be taking one path, sometimes it could be taking another path, right? So in case if it takes, so sometimes it might work when it takes a proper path, but then if there is alternative path, and if there is some server in the middle that doesn't support EAI, then that might fail. So you might encounter that sometimes the email get delivered, sometimes the email may not get delivered. So these sort of issues can also happen. So I think, this is the sort of summary that I wanted to highlight. Also, it is also possible to downgrade and send this email, but then that is not really recommended, because if you downgrade this email and send it, the sender will not be able to recognize anything, because all those characters, say in Myanmar script, to the receiver, it will be shown as like squares and boxes, and it's not really the characters that will be shown, so it's not really recommended. So I think I will, given the time, I will just wind up my session, and if you have any questions, we can have some questions, or feel free to write to me, or send me some questions later, or we can get into the quiz. Thank you.
Thank you, Mr. Champika. So, any question about the presentation? Raise hand လုပ်လို့လည်းရတယ်เนาะ raise hand လုပ်ရင်ကျွန်တော်ပြန် unmute လုပ်ပြီးတော့မေးလို့လည်းရတယ် message မှာလည်း type လုပ်ပြီးမေးထားလို့ရတယ် Any other question? There's one question. Yeah.
Yeah, I can see that. What's the current status of IDNAI in the APAC region? Actually, so in terms of some countries, of course, now I have to actually probably, I should, because this question is a quite broad question. So now when you mentioned about the status, one option is, of course, different economies, different countries having their own top level domains or own label generation scripts is a one area, because before you really have a domain name or email addresses, you have to have, you should be able to have domain names in your own language. So in this case, number of countries in the APAC region, they have formed what we call label generation panels to define rules for their local language scripts. Now, in the case of, I think, top of my head, I cannot exactly tell the number of countries, but in worldwide, around 60 different scripts have been delegated in the top level domains for their country code top level domains, right? That is the current status worldwide. And so even in the APAC region, I think, probably about half of that, maybe around that in the APAC region. Now, coming to Myanmar's case, I think given that this is the Myanmar audience, as I said earlier, in Myanmar, still so far we don't have a TLD country code CCTLD string for Myanmar, right? So this is something that PTD or the .mm registry operator can work maybe in the future, requesting for a country code top level domain for local language or Myanmar script. And the other thing is, so this is for the country code, right? And the other thing is for any given script in Myanmar language, right? Not only just the Myanmar country itself, but any given script. Say, for example, like even second levels, for example. So in this case, the experts, language experts in the country has to get together and define language rules, because the thing is that um, it is the Myanmar community who knows how their language rules are and how the language is being defined and so on. So there's a lot of progress in this area, because in Myanmar, we already have what we call a language rules generation panel for the internationalized domain names. Already that has been formed, and they have already analyzed all the language rules in Myanmar local language scripts, and then they have already given a proposal. So this proposal is currently under the evaluation of an integration panel. So maybe in very soon, this will be finalized. So that is the case with Myanmar. So I think, I just, try to answer it a little bit broader way so that the background context is also covered.